The periodic table is the graphic organizer of all of the elements that we've ever discovered. So chemistry is the study of matter, and elements are the simplest forms of matter. They cannot be simplified in any way, and they are arranged by what we call atomic number, so 1 through 100 and something, which in general correlates with how much they weigh. So you'll see as they increase in atomic number, the masses are also going to be increasing from the left to the right and then from the top to the bottom. The two most basic ways that the elements are differentiated is by row and column. So if you look at the first group of numbers right here, 1 through 7, that represents the horizontal rows. They don't all have the same number of elements in them, but it doesn't matter. So like 1 only has 2 elements, 2 and 3 only have 8, and then they get a lot more as you go down the periodic table. These two sections down here, okay, you'll see that they don't have period numbers, and that's because they actually go inside of the periodic table. So if we look at number 57, okay, it is followed by 72 instead of 58, and that's because 58 through 71 is actually this first row right here. So technically, CE through LU is actually period 6. There's no chemical reason why these are taken out of the periodic table. It's all about space. So it's easier to print if we take those two columns and we just move them down a little bit, and then you can print them on a regular 8.5 by 11 piece of paper. The other way we organize the elements is by vertical columns, and there's two different ways that those are numbered. There's the 1 through 18 numbers that you'll see at the very top, and then we have what we call A group and B group. So there's 1A through 8A, but there's also the B section, which is the middle of the periodic table. The easiest way to remember the difference between the two is if you use the gray area right here to write period across, and then use the R to write group going up and down. You'll never get the two confused. In the empty space above your periodic table at the very top, you do need to know that the groups are also referred to as families, and that is because elements that are in the same column together tend to have similar properties, so they react to their environment in similar ways. So for example, in group 1, lithium, sodium, and potassium are all very similar to each other. Across the periodic table, nitrogen and phosphorus are similar, fluorine, chlorine, bromine, iodine are all very similar, etc. The state of North Carolina says that you need to know the names of 4 of the different families. So underneath what you just wrote at the top, okay, you need to know that group 1A are referred to as the alkali metals. So that's lithium, sodium, potassium, rubidium, cesium, francium. And then group 2 is the alkaline earth metals. So that's going to be everything in this column. On the other side of the periodic table, we're going to skip over to where fluorine is. Group 7A, these are referred to as the halogens. And then last but not least, we have the last group, which is 8A. They are referred to as the noble gases. For this next part, you're going to need 4 different colors, either markers or crayons. If you're using markers, I recommend that you just outline the sections that we're about to talk about. If you use crayons, you can shade it in. You just need to make sure that it's not too dark. So whichever color you choose, okay, we're going to start by outlining groups 1 and 2 together. So hydrogen and beryllium all the way down to the bottom and then back up to the top. And then across on the other side of the periodic table, we also need to outline the box that helium is in, because technically helium could also be set right here on the periodic table. It does have a lot in common with group 2 as well as group 18, so it does all go together. And then at the very bottom, in that empty space below your periodic table, you can start a key. This section that we just outlined / colored in is referred to as S block. The second section is on the right side of the periodic table. We're going to start with boron right here, and it makes almost a perfect square. So go down to TL, and then over to RN, and then back up, and then over. And if we add to our key, then we're going to call this P block. So you might notice that the only 2 sections that we've outlined are the ones that are referred to as A group. Okay, and the name of those 2 sections collectively is the representative elements, so I would add that to your key also. Your third color is going to be used for the middle section, okay, right here in between S and P block. Okay, we're going to outline what we call D block, and you can add that to your key down at the bottom. And then you probably figure there's only one section left and we only have one color left. So the last section is the very bottom of the periodic table. Okay, and we're going to outline that with our last color and put it as F block. Okay, the B groups are referred to as the transition metals. For the next part, you're going to need to use a really dark marker or a Sharpie. We're going to outline just a few specific elements, and we'll start with number 5, boron. So take your Sharpie, and you just want to really accentuate the borders of boron. The next one is silicon, number 14, so you want to outline number 14. Okay, the next two are 32 and 33, so we're going to outline both of those. Okay, and then we'll do 51 and 52. And then the last section is 84 and 85. These 8 elements separate the periodic table into 3 basic sections that are divided by their properties. So if you think back to the names that we just went over, like group 1, alkali metals, group 2, alkaline earth metals, this section and this section referred to as the transition metals, and even over here in P block, you have aluminum, tin, lead, elements that you know are metals. Everything from the left side of this staircase and over are the metallic elements. So maybe up here, you can write metals and put an arrow going to the left, or you can put it down here, wherever you want that makes sense to you. Everything on the left side of the periodic table are metallic elements. On the other side of the staircase, so carbon, phosphorus, selenium, iodine, radon, all of these are the opposite, which we call the nonmetals. Oops, I just ran out of room. There you go, nonmetals. So obviously there's a lot fewer nonmetals than there are metals. The 8 elements that we outlined that separate the metals from the nonmetals are referred to as the metalloids. So what exactly does this mean? Just a brief little review. All of those left side elements, what they have in common is in general they're shiny, they're malleable, ductile, which just means that they can all change shape easily. They're conductors of heat and electricity. They have high melting points, so they tend to be solids at room temperature, and they make positive charges if they become charged. Based on the wording, you should probably realize that non-metal means opposite of metal. So rather than shiny, they're dull. Instead of being malleable, we call them brittle. Rather than being conductors, they're insulators. They have low melting points, so they can be liquids and gases at room temperature, and they make negative charges. The metalloids exist somewhere in between. So they can have a mixture of properties. This is an example of silicon, which is shiny like a metal, but it's also in these like rocky clumps, which indicates that it's brittle. So it has a characteristic of metals and a characteristic of nonmetals. The vocab word that you want to recognize that goes with them is that they are semiconductors, which means they can conduct, just not as well as a regular metal.